In this set of notes, we're going to talk about writing equations of parallel and perpendicular lines in slope-intercept form. Parallel lines, if you remember, are lines that never intersect. The symbol that we use for parallel looks like absolute value bars, but is a little closer together. Every once in a while, you'll see the symbol maybe written in a slanted way. Slopes of parallel lines, if you remember from yesterday, are the same. So if the slope of one line is 3 and a line is parallel to it, it will also have a slope of 3. Perpendicular lines are lines that intersect at 90-degree angles. The symbol for perpendicular is an upside-down T. And slopes of perpendicular lines are two things. They're opposites, so that means that one will be positive and one will be negative, and they're also reciprocals. Both of these things are going to be true about perpendicular lines. So the first thing that we're going to do is we're going to look at a set of lines and determine if any of them are parallel or perpendicular, just by looking at their slopes. So in example 1, I have line A. In example 1, I have line B, and I also have line C. So the first thing I want to do is find the slopes of lines A, B, and C. So on line A, since y is already isolated, I can identify its slope as 5. It's the coefficient of x. For line B, in order to find the slope of that line, the first thing I'm going to have to do is to get y by itself. So first I'm going to minus x from both sides. That gets me 5y equals 2 minus x. And then I'm going to divide both sides by 5, which will get me, I'm just going to do this up here, y equals 2/5, because that's my first bean. And then minus, on this part it's going to be important to remember that there's really an invisible 1 here. And so this is going to be minus 1/5 x. And so what this means about my slope of line B is that my slope of line B is going to be negative 1/5. Now I'm going to continue on with line C, and so on line C I also need to get y by itself. To do that, the first thing I'm going to do is add 2x to both sides. This will give me the new equation, negative 10y equals just 2x. Then I would divide by negative 10, which would get me y equals negative 1/5 x. And so in this example, now that y is isolated, I can see that my slope is negative 1/5. Now that I know my three slopes, I can analyze them to determine if any of my lines are parallel or perpendicular. So the first thing I notice is that line B has a slope of negative 1/5 and line C also has a slope of negative 1/5. So I can say that line B is parallel to line C. The next thing I notice is that A is positive 5, B and C are both negative. Also positive 5 as a fraction would be 5 over 1, which means its reciprocal would be 1/5. So line A, positive 5, line B, negative 1/5. They're opposites and reciprocals. So that means A is perpendicular to B, A is also perpendicular to C. Your turn to try. Pause the video to complete examples 2 and 3. Make sure you find their slopes by getting them into slope-intercept form first, meaning that y is isolated. Find the slope of each of the lines, and then put your answer near on the line provided about which lines, if any, are parallel or perpendicular. Pause the video, press play when you're ready to check your answers. So first thing on example 2, I knew line's A slope is negative 3. It was already in slope-intercept form. To find the slope of line B, I added x and then divided by 3. The key here is that, remember, that's going to be a 1/3. And then for line C, I add minus 2x and then divided by negative 6. 4 over negative 6 reduces to negative 2/3, and then negative 2 over negative 6 reduces to positive 1/3. So line C also had a slope of positive 1/3. So that meant that lines B and C were parallel. And then since line A is negative and B and C are positive, A is 3 over 1, B and C are 1/3. That also meant that A was perpendicular to B, A is also perpendicular to C. On example 3, I started by isolating y on line A by minusing 2x and then dividing by 6, which got me a slope of negative 1/3. B was already in slope-intercept form, so that had a slope of 3. And then C, I added I minus 4.5x and then divided by negative 1.5. I just did some math over here in case, you could use a calculator, but I thought of it as 6 divided by negative 1.5, 6 divided by negative 3/2, that's the fraction. So then I changed it to multiplying by the reciprocal, and then 3 went into 6 twice, and 2 times negative 2 is negative 4. And then for minus 4.5x divided by negative 1.5, I moved the decimal over once on top and bottom and really thought of it as 45 over 15. And because they're both negative, it was positive and positive 3. So line C also had a slope of positive 3. So in this case, lines B and C were parallel. A and B, opposites and reciprocals again, so they are perpendicular. And A is also perpendicular to C because they're also opposites and reciprocals. So the first part of this was just determining if lines were parallel or perpendicular based on their slopes. Now we're going to use whether or not lines are parallel or perpendicular to help us come up with a slope-intercept equation. So on example 4, and for all of these, what's going to be important to know is that we have two lines. We have a blue line on the graph, and then we also have a red line on the graph. The blue line is the line that we're trying to create the equation of, and the red line is the line that we know the equation of. So we have a lot more information about the red line than we do about the blue line. And the thing that we're being told here is that they're parallel. So the information about the red line that we know is that the red line has a slope of 3 and a y-intercept or a b value of -1. Because it's in slope-intercept form, I can identify those two pieces of information, slope and b value. Because I'm being told that they're parallel, what that means is that blue and red are going to have the same slope. So since they have the same slope, that also means that the blue slope is going to be 3. I was also told at the start that the blue line passes through the point -3, -5. So I now know its slope and an x value and a y value, which will be enough information to find b. And I'm going to do this the way I always have. It's just that I wasn't explicitly told the slope. I had to know they were the same because they were parallel. So I'm going to use -5 as my y value, m is 3, my x value is -3, and I'm going to solve for b, and then my last step would be to add 9 to both sides, which means b would equal 4. And so then this means my equation of my blue line would be y equals 3x plus 4. And if I compare, they have the same slope, but they have different y-intercepts. So you're going to try examples 5 and 6. So in both cases, you're trying to complete the equation of the blue line in slope-intercept form, and you're being told in both cases that they're parallel to the red lines that are here. Pause the video, press play when you're ready to check your answers. So on example 5, I know that the red line has a slope of -1 and a y-intercept of 5. The only thing I really need is the slope, and since they're parallel, that means the blue line is also going to have a slope of -1. It also passes through the point with an x value of -2 and a y value of 11. So using that information, I found that the blue line has a b value of 9 for a complete equation of y equals -1x plus 9. Example 6 is a little bit different because on the red line, I can't say its slope until y is isolated, and so to do that, I had to subtract 2x, which means my slope is -2. Once I have that slope, I can use that slope for my blue line as well. I used y is 3, -2 is my slope, x is -3, -2 times -3 was 6, and then -6 from both sides to get a b value of -3. Don't forget to complete your equation in slope-intercept form, y equals -2x minus 3. Now we're moving on to perpendicular, so very similar situation, but now their relationship with their slopes won't be that they're the same. They'll have a different relationship. So I still have two lines. I have a line that's passing, or that's blue and is passing through a point, and that's all I know about it, but then I also know it's perpendicular to the red line. So for the red line, the key piece of information that I'm going to take out is that it has a slope of 2. Because it's perpendicular, what that means is that when I bring it over here to use it for my blue line has to be the opposite, meaning if it's positive, it has to be negative, and it also has to be the reciprocal. So the slope, red slope is 2, my blue slope is going to be -1/2. Then for blue, I also know that it has an x value of 4 and a y value of -5. So I can use this information to help me find its missing y-intercept. So -5 equals 1/2, -1/2 times 4 plus b, -5 equals -2 plus b, add 2 to both sides, -3 is my b value. Now I can complete my blue equation, y equals -1/2x minus 3. One thing I like about the color coding is that it's important not just to use this slope at the end, but to use it throughout this entire blue equation. Some people accidentally use the number 2 here, but if it was the number 2, that would have been the red slope. So I like using color in that way to differentiate between the two lines. You're going to try examples 8 and 9. In both cases, you're trying to come up with the blue slope-intercept equation. You know that it's perpendicular in both of these examples to the red line because of this symbol right here. Pause the video, press play when you're ready to check your answers. So on example 8, I know that the slope of the red line is 4, which means the slope of the blue line is going to be the opposite and the reciprocal. So it's changing from positive to negative, and it's flipping upside down. I want to make sure I use this slope throughout the entire problem. I can also replace y with 3 and x with 4. That got me -1, and then I added it over to get a b value of 4. So my final answer in slope-intercept form is y equals -1/4 x plus 4. On example 9, like above, I can't say the slope of the red line yet until y is isolated. I did that by adding 4x to both sides, so my slope was 4. That also meant my slope of my blue line was -1/4. My x value was 4, my y value is -2, my slope is -1/4, which allowed me to find my b value of -1 for a final answer of y equals -1/4 x minus 1.